Test 3 Part 2 Calculus and Trigonometry. Question 4. 1. We have two parts in question 4. The first part, ABC is a triangle in which A equals 5 centimeters, B equals 7 centimeters. Measure of angle A equals 40 degrees. Find the measure of angle B. So we have A equals 5 centimeters. A is the length, denote to the length of the side BC. It's equal 5 centimeters, and the length of AC, denoted by the symbol B, equals 7 centimeters, and the measure of angle A equals 40 degrees, and the required is to find the measure of angle B. This angle opposite to the side AC. Using the sine rule, we have 5 over sine 40 equals 7 over sine B. Again, 5 over sine 40 equals 7 over sine angle B. And from this, we can calculate the measure of angle B. First, we calculate sine B. So, cross multiplication, sine B equals 7 multiply sine 40 divide 5, and we write it sine B equals 7 multiply sine 40 over 5, which equals 0.8999. So measure of angle B equals sine minus 1, shift sine this number, shift sine 0.8999, which equal approximately 64.15 degrees. Part 2 from question 4. Find the value of A, which makes the function f is continuous at x equal to. When the function is continuous, the left limit equals right limit to the function f of x. And we write it, the function f is continuous at x equal to, then limit f of x when x tends to 2 from the right, here from the right, equals limit f of x when x tends to 2 from the left. What is the value of f of x from the right of 2? It is equal x squared minus 1. And the value of f of x when x tends to 2 from the left, in this branch, the value of f of x is x minus 2a. So we write it, limit x power 2 minus 1 when x tends to 2 from the right equals limit x minus 2a, as x tends to 2 from the left. Here in this limit, x is less than 2. X is always less than 2. That is the meaning of x tends to 2 from the left. And we calculate it, substituting x equal to, so we have 2 squared minus 1. So 2 squared minus 1 equals 2 minus 2a, also substituting x equal to. So we have 2 minus 2a, and we calculate it, 2 squared minus 1 equals 3, as 2 squared equals 4. 4 minus 1 equals 3, equals 2 minus 2a, and we have 3 minus 2 equals negative 2a. So 1 equals negative 2a, and the value of a equals negative 1 over 2. Question 5. Discuss the existence of limit f of x when x tends to 0, where f of x equals tan 2x over sine x when x greater than 0, and f of x equals 5x plus 6 over x plus 3 when x tends less than 2. We want to discuss the existence of the limit, if it exists or not. The limit exists when the limit from the right of 0 equals the limit of f of x when x is less than 0. So we calculate it. Solution. First, A, because in this question we have two questions. In the first part we have A and B. So to answer A, we calculate f of 0 from the left, which equal limit 5x plus 6 over x plus 3 here, as x tends to 0 from the left, substituting x equals 0, so f by 0 equals 0, and here we have 0 plus 6 equals 6 over 3 equals 2. When you substitute x equals 0, you have 2. 5 by x equals 0 plus 6 equals 6. So the numerator equals 6, and substituting x equals 0 in this part, we have 0 plus 3, which equals 3. So 6 divided 3 equals 2. So the left limit equals 2, and you calculate the right limit. F of 0 from the right equals limit tan 2x over sine x, as x tends to 0 from the right. And to calculate this limit, multiplying up and down by x. So we write sine 2x over x equals x over sine x. And note that tan 2x over sine x equals this fraction, equals tan 2x over x multiply x over sine x. Again, when you cancel x with x, you got the original fraction, tan 2x over sine x. So we calculate the limit. Tan 2x over x when x tends to 0 equals 2. It is the rule, it is the law. And so this fraction equals 2. And the limit x over sine x as x tends to 0 equals 1. So the limit of this fraction equals 1, and the limit of the first fraction equals 2, and 2 multiply 1 equals 2. So the left limit equals the right limit, and we write it f of 0 from the left equals f of 0 from the right equals 2. So limit f of x when x tends to 0, this is required, is exist and equals 2. To find the limit 4 minus root x plus 15 over 1 minus x squared as x tends to 1. When you substitute x equals 1 in this fraction, what you get? You will get 0 over 0. As when you substitute x equal 1, so we have 1 plus 15 equals 16, and root 16 equals 4. So the numerator will be 4 minus 4, which equals 0. And when you substitute x equals 1, so we have 1 power 2 in the denominator, and it will be 1 minus 1 also equals 0. So when you substitute directly with x equal 1, you will get 0 over 0, and it is unspecified quantity. So to solve this limit, we multiplying up and down by the conjugate of numerator. What is the conjugate of numerator? The numerator is 4 minus root x plus 15. So its conjugate equals 4 plus root x plus 15. So multiplying up and down by 4 plus root x plus 15, 4 plus root x plus 15. So the result will be the first term square, it's 4 square, which equals 16, minus the root square, and root x plus 15 all square equals only x plus 15, but we have the negative sign, so it is equal negative x minus 15. When you multiply 4 minus root x plus 15, multiply 4 plus root x plus 15, you will get the first term square, because this is a difference, the factorization of difference of two squares. So you will have 4 square, it's 16, minus the root square. The square of the root equals the expression inside the root, which equals x plus 15. Multiplying by negative, so it is equal negative x, we write it, negative multiply positive equal negative 15. And we factorize the denominator, 1 minus x square, here it will be 1 minus x multiply 1 plus x, and we write it here again, and we write this conjugate 4 multiply root x plus 15. Again, when you substitute x equal 1, you will get 0 over 0. What is the 0 factor? The 0 factor is x minus 1, as x tends to 1. Here we have 16 minus 15 equals 1. 16 minus 15 equals 1. So this numerator equals 1 minus x. And this is the 0 factor. Again, 16 minus 15 equals 1. 1 minus x equals 1 minus x. So we can cancel it to be in this form. So the numerator will be 1, and the denominator equals 1 plus x after you cancel 1 minus x with 1 minus x here. So we have in the denominator 1 plus x multiply 4 plus root x plus 15. This conjugate, we write it again, and we substitute with x equals 1. When you substitute x equal 1, so 1 plus x equals 2, and when you substitute x equals 1, what you get here, you get 1 plus 15. Under the root, it is equal 4. Root 16 equals 4. 4 plus 4 equals 8. 8 multiplied 2 equals 60.